Well, today we are going to answer the question, what does it mean to expand a binomial product? Oh my gosh, there is like just a whole heap of fancy maths words in there, but they're not that scary. Let's first of all explain what the heck a binomial product is. Okay, a product is just what you get when you multiply two numbers together. So 2 times 3, the product is 6. So product just means the result when you multiply, but binomial, what does that word mean? Well, if you think about that prefix bi, bi, think of a bicycle has 2 wheels, a biplane has 2 wings. So bi, the prefix, means 2. So we're multiplying expressions that have 2 terms. So a binomial has 2 terms, and a product is what you get when you multiply them together. Best we have a look at an example, and we're going to go through a couple of examples. Pause if you need to, and let's expand these binomial products. We've got a bracket with x plus 2 and a bracket with x minus 3. So they are my 2 binomials. X plus 2 is the one binomial. This is the second one. Because they're in brackets, that means it's this bracket multiplied by this bracket. And when we finish doing our expanding, we'll have no brackets left. So let's go through the process. There's a couple of ways of doing this. The one that I prefer, that I want you guys to learn, is what we call splitting the gangs. And here's how it works. Let's pretend both of these sets of brackets are a gang. This is the x plus 2 gang, and this is the x minus 3 gang. We are going to split one gang, and we're going to leave another gang intact. Doesn't matter which one. Usually I tend to do the first one. So we are going to take these 2 gangs. I'm going to take the brackets away from this one, which gives them the chance, the x the chance to escape. Gets away from the gang. And this gang always stays together. In fact, another copy of this gang comes over here, and now we've split the gangs, right? So I've split the x plus 2 into its 2 terms, x and plus 2, and I've multiplied each of those terms by the other set of brackets that we kept together. Now, hopefully, when you look at that, you can see, well, hang on, we've, in a previous lesson, done expanding brackets, where we take this letter or number out the front, and we multiplied by each of the terms inside the bracket. So let's do that. X times x gives me x squared. X times negative 3 gives me negative 3x. And you'll see I'm just writing out each of my multiplications, the answer, as I go along. So now let's expand the second set of brackets. Plus 2 times x gives me plus 2x. And plus 2 times a negative 3. Now, remember, we've got a positive times a negative here. So I like to just do the numbers first. It's going to be 2 times 3 is 6. But because I've got a positive and a negative, that will make it a negative 6. So the last thing now to tidy all this up is just simply collect the like terms. And hopefully you may have seen in a previous video, this thing I like to do, particularly until you get used to collecting like terms, is actually split the expression into its terms. So every time you see a plus or a minus sign, it's the start of a new term. Split it there because the term has to include that sign. And I can see these two are like terms. They have the same letter or the same pronumeral, minus 3x plus 2x. So I can add those two together. And when I've got minus 3 x's, I've got negative 3 x's, I add 2 more, I've got negative 1x. In other words, I've just done the numbers, if it helps to think of it that way. Minus 3 plus 2 gives me minus 1, but they were x's, so I have to put the x back in. The very last step in algebra, hope you remember, we don't write the number 1. If it's got a 1 in front of a letter, we treat it as if it's invisible. So minus x is the same thing as minus 1x. We've done it. We've expanded that binomial product. You guys rock. But let's have a look at 2 more examples, get slightly more tricky on each one as we go, but the ideas stay the same. Expand this. Well, I'm going to split up this first gang. So I'm going to take the m and I'm going to split it off, and then I'm going to multiply it by the second gang. Then I'm going to take my minus 5 from the gang that I've split and multiply it by the gang that I kept together. And now I've got an expression that I can go ahead and expand. M times 4m gives me 4m squared. M times the negative 3 gives me negative 3m. Minus 5 times the 4m gives me negative 20m. And finally, negative 5 times negative 3. Now, 5 times 3 is 15, but 2 negatives make a positive to get me a positive 15. Are there any like terms? Yeah, I can see the m's here. So I've got negative 3, take away another 20, gets me negative 23. But don't forget that they are m's, so I leave the m there. And we have now expanded that one. All right, hopefully you can see the ideas were exactly the same. Here's a twist. One last example. Expand this one. Now you'll see this isn't, these aren't both binomials. This one is, it's got 2 terms. This one's actually a trinomial. It's got 3 terms in it. But guess what? The process works exactly the same. If you got something that looked ugly like this, let's just go through, do the things we just practiced, and see if it works out okay. I'm going to split this first gang. Okay. In this case, it's definitely easier to split the one that's smaller, the binomial. So that will be my x, is the bit that I've taken out first, multiplied by the other gang. Then I'm going to take the plus 3, because this is the gang that I've split, and multiply it by the gang that I've kept. Now I'm going to go through their trinomials. Doesn't matter. I'm just going to go x times 2x gives me 2x cubed, right? Because 2x squared times x is 2x cubed. X times negative 3x gives me negative 3x squared. X times plus 7 is a positive 7x. Working my way along, I'm just doing my multiplications as I go. This gives me plus 6x squared. This gives me negative 9x. 1, 2, 3 times negative 3x. And 3 times 7 is 21. We are nearly there. I'm going to go through and see, are there any like terms? Now with something like this, it's probably best just start at the front and have a look. Well, I've got something that's cubed. Are there any other x cubeds? No, there aren't. So there's no like terms to collect there. Negative 3x squared. Are there any other terms that are x squared? Well, yes, there is. There's negative 3x squared and plus 6x squared. So when I add them together, I've got plus 3x squared. Are there any like terms with the x's? Well, yes, there's a 7x, take away 9x, gives me negative 2x. And there's no like terms for the 21, so I can leave it on the end. Ladies and gentlemen, you just expanded something that looked really ugly to start with, but using those techniques that we practiced way back in our first example, you smashed it out. You guys are amazing. Well done.